Good morning. Today we are correcting CO22, finding prime factors of a number. So breaking it down to all the primes. We did some in class yesterday, and I noticed some of us were working ahead instead of following along, and we were doing things incorrectly. We need to understand how to do this, and we need to stop trying to work ahead and just listen. Sometimes I go through mistakes that are made, like I did yesterday. We did our prime factors and we had put a 4 in it and forgot to break the 4 down into two twos. So it's very important that we are paying attention and listening so we don't continue making those mistakes. So we should not be looking ahead to our next objective. We should be just not looking ahead to our next objective. Focused on today's. Stop working ahead. That's why people are getting things wrong on the tests, because we're not devoting all of our energy to each objective as we do it, and we're making simple mistakes. So let's focus on our correcting, making sure we see what mistakes we've made. I pointed a lot out yesterday before class was done, but I did not get to everyone. Make sure you understand what mistakes you made so we don't continue to make them. Our first one, our prime factors are 2 times 2 times 3, and we had to list 3 factor buddies, 1 and 12, 2 and 6, 3 and 4. The next one, our prime factorizations, the prime factors are 3 times 5, and our factor buddies would be 3 and 5, 1 and 15. Then we have prime factorizations as 3 times 3 times 3, or you could put 3 cubed. Our factor buddies are 3 and 9, 1 and 27. Then we have 2 times 2 times 2 times 5, or you could put it as 2 cubed times 5. Either one is acceptable. They mean the same thing. We have factor buddies of 8 and 5, 1 and 40, 2 and 20, 4 and 10. Remember, you had to list at least 3 of them. So if you did not list your factor buddies, if you miss parts of directions like that on the test, it is wrong. So you need to make sure you are following all the directions. The next one, 2 times 2 times 5 times 5, or you could say 2 squared times 5 squared. Some of us might have put 5 times 2 times 5 times 2. It doesn't matter the order that we multiply, we still get the same answer. So as long as you have those factors that you're multiplying through, it doesn't matter the order they're in, it would still be correct. Factor buddies of 100 would be 101, 2 and 50, 4 and 25, 10 and 10, 5 and 20. Then we have 2 times 2 times 11, or 2 squared times 11. Factor buddies would be 1 and 44, 2 and 22, 4 and 11. For 54, the factorization, prime factorization is 2 times 3 times 3 times 3, or 2 times 3 cubed. Factor buddies would be 1 and 54, 2 and 27, 3 and 18, 6 and 9. For 75, we have 3 times 5 times 5, or 3 times 5 squared. Factor buddies would be 1 and 75, 3 and 25, 5 and 15. Then for 300, our prime factors are 2 times 2 times 3 times 5 times 5, or 2 squared times 3 times 5 squared. Lots of factor buddies to choose from here. We have 1 and 300, 2 and 150, 3 and 100, 4 and 75, 5 and 60, 6 and 50, 10 and 30. Again, you had to have 3 listed. For 81, we have 3 times 3 times 3 times 3, or 3 to the 4th power. Factor buddies would be 1 and 81, 3 and 27, 9 and 9. For 23, it would be 23 times 1 So 23 times 1. So technically you could have just put 23 because 1 isn't a factor, a prime factor. For the factor buddies, it would just be 23 and 1. For 99, we have 3 times 3 times 11, or 3 squared times 11. Factor buddies would be 1 and 99, 3 and 33, 9 and 11. Questions on any of these? Madison, you had your hand going up?
Oh, no, I was just making sure that it was.
Okay, yep. Did anybody have a hard time getting some of these prime factors? Because I know there were a lot of us yesterday that weren't getting them right. Layla? The 23? Yeah, that one confused a lot of people. I had people coming up and asking me about it. They're like, but there's no factor buddies. But there is a factor pair. So if every number is going to have a factor pair that you can go down to. So every single number you can make a tree out of. Sometimes it's going to be a really small tree and we can't go any more than just itself times 1. If it is already a prime number, it's still going to make a tree, it's just going to be a really small tree. So you don't put no primes because that's not true. There is a prime, right? So always make a tree. Sometimes just know it might be a small tree. Sometimes it's going to be a really big tree. It just depends on the number and how many times we have to break it down. Liv.
I just didn't list like 3 factors. I kind of just like listed 2, so like that's.
Yeah, so that's a good thing to catch now. So when it's time for the test, you remember to read the directions completely. Because I have had students only answer part of a question and then they get the whole thing wrong on the test. So make sure you're always reading the full directions. Anybody not sure how I got any of these prime answers? There should be no scissors out. Anybody make mistakes not breaking down a number far enough down to the primes? Because that's a very common mistake, Ava.
Well, I did that on like I think 1 of them, but also some of them I forgot to do. Like for the one that was like 100, I forget to do like 101.
Oh, you did. So you only had to list 3 primes or 3 factor pairs. So if you listed 2 other or other ones, that would have been okay. You didn't have to list every single one. I just wrote them all out because I didn't know which ones people were going to list. One thing that some of us caught that is a very, very, very common mistake that people make. Let me see if I have it. I didn't use 6 as one of my pairs. But for 54, some people did 6 and 9. And then when they broke up the 6 and 9, every year I see at least 2 or 3 people breaking up that 6 into 3 and 3. Why would it not be 3 and 3? Hannah?
Because 2 times 3 is 9.
3 times 3 is 9. We need to multiply. This was adding 3 plus 3 to get 6. We want to know what we're multiplying. So every year I have people accidentally do 3 and 3 instead of 2 and 3. So that's one of those common mistakes I want you to be thinking about, saying, do I multiply these numbers together or did I accidentally add? Callie.
Yeah, because one of them for 9, I thought we could do either, so on some of them I added 6.
And it's a very, very common mistake. Callie's saying for the 9, she accidentally put 3 and 6 because she added them together. You cannot add. It gets confusing when we have our 4 and we see that 4 was broken down into 2 and 2 and 2 plus 2 is 4, but 2 times 2 is 4. So something to keep in mind is always multiplying when we do prime factorization. All right, if you are watching at home, I hope you are well. Come see me if you have any further questions on prime factorization. Have a wonderful day.